Welcome to myprojectbazaar.com. Now let me discuss about the project Iterative closest normal point for 3D face recognition.
In this paper, the common approach for 3D face recognition is to register to prop face to each of the gallery faces and then calculate the sum of the distance between their points. This approach is computationally expansive and sensitive to facial expression variation. In this paper, we introduce the iterative closest normal point method for finding the corresponding points between a generic reference face and every input face. The proposed correspondence finding method samples a set of points for each face, denoted as the closest normal points. These points are effectively aligned across all faces, enabling effective application to discriminate analysis methods for normal methods. These points are effectively aligned across all faces. 3D face recognition. The expression variation problem is addressed by minimizing within this class variability of the face samples while maximizing the between class variability. Then we show that the surface normal vectors of the face at the sampled points contain more discriminator information than the coordinates of the points. Then which to the best of the knowledge have 7 and 4 times less error rates respectively compared to the best methods for these databases. Then this face registration of a prop face to every gallery face makes the approaches computationally very expansive. It's the block diagram of our project. First we will load the input 3D images. The next one is extracted ICNP. ICNP is iterative closest normal point. For iterative closest normal point is extracted to this nose tip and face post correction. Nose region is the first step is pre-processing is to localize the face in the 3D images. Because the nose tip usually has the smallest depth, it can be easily deducted and used to localize the face. However, in some images, because of the out of planned rotation of the head or the presence of the hair in the face, the point within the smallest depth does not correspond to the nose tip. To verify whether a point is actually a nose tip, we use the ICNP techniques described in this method. The next one is denoising. Then the median filter will be applied for nose tip and face post correction images. The next one is input iterative closest normal point. Iterative closest normal point is the rest of these images. We refer to the smooth closest normal point simply as the CNPs. After finding the CNPs, the input face is rotated and translated to reduce the distance between the CNPs and the reference points. The distance between the CNPs and the reference points. The resulting better alignment between the input face and the reference face results is a more accurate correspondence between their points. We repeat the searches of the CNPs. The next one is find the closest normal point for this process. Finally, face is recognized to use to the closest points. We have assumed that they are located on the same cross section of this input face. However, it should be noted that the actual closest points can be located anywhere within the neighborhood of these cross sections. Then this proposed color images give a pixel to pixel correspondence to the respective pre-processed range images. This 3D point has a texture value. Now, in order to check whether a successful correspondence have been established between the reference face and an input face, we have created a specific texture map of the corresponding points from the input face by mapping the texture of these points to their reference points. We obtain such mapping by replacing the pixel values in the range image to the reference face by the texture value of their corresponding points from the input face. Now let's see about the execution part. I am having main.m file, then select the file, right click, then run file. Then here we have to select the figure file for iterative closest normal point for 3D face recognition. Then first of all click the reference images. Then reference images is select the gallery data. Then this one is input images for, then select the images. The next one is, this one is 3D images, so rotate the 3D face. Then rotate the 3D images. The next one is then apply to the ICNP. Then this one is closest point. Then closest ICNP is finding the correct corresponding points across faces is a key factor for the sources of ICNP method versus to this ICP methods. Then this one is closest point. Then this one is input face. The next one is find the nose tip deduction. The nose tip deduction is fine. The next one is face grab. Then this one is scrapped face deduction. The next one is denoising process. Then the denoising is median filter will be applied for input. Then grabbed face. The next one is LDA feature extraction process. LDA feature extraction. Then LDA feature extraction is this proposed face recognition systems. Here we compare the face recognition performance using the LDA in order to show the role of LDA in the proposed approach. Here we compare the face recognition performance using LDA versus using the PCA. As maintained before, one successful correspondence are established across faces. Successful corresponding to this LDA is capable of distancing between geometric changes resulting from expression variation and this resulting from subject variation. Then this LDA significantly is applied to this input face images. Then train features. Then select the source code. Then select train data. Then reading training images. Then select the train and test features. Then next one is recognition. Then it's identify to the recognition process. The next one is analysis. Then the ICP and ICNP performance analysis. Then PC and LDA comparison methods. Then this paper is this. We introduced the ICNP method to effectively find the points that correspond to the same facial features across all faces. We used a surface orientation factor to find the corresponding points denoted as CNPs. We showed that the ICNPs that are deducted from an expression face are the same as those deducted from the corresponding natural face. In particular, the CNPs is to the points to the lips of the reference face or whether the mouth is open or closed in the input phase. We also showed that the successful applications of DA methods for the 3D face recognition can be achieved by using the CNPs. Thank you.